Hello everyone. In this lecture, we will see the classification of control systems. That is, what are the different types of control systems. So broadly, control systems can be classified as natural control system, man-made control system, combinational, that is a combination of these two, natural and the man-made, time varying and time invariant control system. I have combined these two because if you can study this, then it will be exactly opposite to that. Then next is the linear and nonlinear control system, continuous and discrete, deterministic and stochastic, lumped parameter and distributed parameter. And the last is single input, single output and multiple input, multiple output control systems. Coming to the first one, natural control system. Here the biological systems, the systems inside the human being are of natural type. So for example, you can consider as example as perspiration. That is the perspiration system which is inside the human being. And here this system, it will activate the secretion glands. It will secrete sweat and regulates the temperature of the human body. Okay. Next, second is the man-made control system. The various systems we are using in our day-to-day life are designed and manufactured by human beings. So such systems like vehicles, switches, then various controllers and many more are called as man-made control systems. One more example, you consider it as automobile system with gears, then accelerator, braking system, which is a good example of the man-made control system. Third is the combinational control system, which is a combination of both natural and the man-made control system. For example, you can consider the driver driving a vehicle. So in such system, for successful operation of the system, it is very necessary that the natural systems of a driver along with the systems in vehicles which are man-made must be active. But for the engineering analysis, control systems can be classified in many different ways. So some of the classifications are, first one is the time varying control system. Now, time varying control systems are those in which the parameters of the system are varying with the time, and it is not dependent on whether the input and the output are functions of time. So for example, you consider a space vehicle whose mass will decrease with time as it goes up, that is as it leaves the earth, and the mass here, it is a parameter of the space vehicle system. One more example, you can consider the example of a rocket. Their aerodynamic damping, it can change with time as the air density changes with the altitude. Fine. Now next type is the time invariant control system. In time invariant control system, even though the inputs and outputs are functions of time, but the parameters of the systems are independent of time, which are not varying with time, and these are constants. Okay, then such system is called as the time invariant control system. So here example you can consider as the different electrical networks which consist of the elements such as resistances, inductances and the capacitances, which are time invariant system, as the values of the elements of such system are constant and not functions of time. Okay, so here you can see you are giving the input f of t and output is c of t. So the parameters of the systems are functions of time in time varying control system, whereas here the parameters of the systems are constant and not functions of time in time invariant control system. Then next type is the linear control system. So a control system, it is said to be linear if it satisfies these properties. That is, first is the principle of superposition. Okay, the principle of superposition is applicable to the system. That means the response to several inputs can be obtained by considering one input at a time, and then you need to algebraically add the individual results to get a single output. And mathematically, the principle of superposition, it is expressed by two properties. First is the additive property and second is the homogeneous property. In additive property, suppose we have two variables, that is x and y, which belongs to the domain of the function f. Then we can have f of x plus y is equal to f of x plus f of y. That is the additive property. And second is the homogeneous property, which says that for any x which belongs to the domain of function f and for any scalar constant alpha here, or a I have taken a as the scalar constant here, then we can have it as f of a comma x is equal to a into f of x. So this is the homogeneous property. Then the next condition is the differential equations which describes the system, it must be linear, that is having its coefficient as constants. And the last is the response. Okay, it should vary linearly with the input, that is forcing the function for the linear systems. So here one example is there. You are having a resistive network, that is it is having all the resistances. It doesn't have any capacitance or inductor here. So here this is the response for this electrical network, which is linear. Okay, therefore there exists a linear relationship between the input and the output. So this is about the linear control system. Next is the non-linear control system. Non-linear control system, a system is said to be non-linear control system if it does not satisfy the principle of superposition. Okay, whereas linear was satisfying the principle of superposition. And the equations, system equations are non-linear in nature, that is f of x is equal to x square. And if you have f of x1 plus x2, then it will be of the form x1 plus x2 whole square, whereas it will be not equal to x1 square plus x2 square. Okay, that is actually it should be like this, but we are getting this. And f of alpha into x or f of a into x will be equal to ax square. Okay, whereas in previous one we were having it as a into x square, but here it is ax whole square. Okay, and the equations of the nonlinear systems involves these nonlinear functions. And last is the output. It does not vary linearly with the input. Okay, so here you can consider this as an example where the voltage current equation of a diode is exponential and nonlinear. Thus the diode circuit, it is an example of the nonlinear systems, and this is the response of this electrical network. Now there are some nonlinearities present in the nonlinear control systems. So first is the saturation. It means if input increases beyond certain limit. Okay, suppose we are increasing the input here, and we are getting the output. For some extent of input, we are getting the output as linear, but after beyond some limit, certain limit, the output remains constant. That is, it does not remain linear. Then here you have the dead zone. So here what happens is in some big walls, though the force increases up to the certain value, the wall does not operate. Okay, so there is no response for certain time, which is called as the dead zone. Okay, and the last is the exponential. This is which we have seen for the diode circuit. Okay, that is the exponential. Now next comes the continuous time control system and discrete control system. First we will see what is a continuous time control system. So here in continuous time control system, all the system variables are the functions of continuous time variable t. And example here is the speed of a DC motor using a tacho generator feedback. So here you can see we are getting a continuous signal. Next is the discrete time control system. Here at any time t, they are dependent on, in discrete time control system, one or more system variables are known only at certain discrete intervals of time. Here you are at any time in this continuous time control system, at any time they are dependent. That is, at any time t, the output is dependent on time. But whereas in discrete time control system, here it is the output is known only for the particular time intervals or the discrete intervals of time. Example here is a microprocessor or the computer based systems which use the discrete time signals, and these are used in the digital controllers. Then comes the deterministic control system. So a control system is said to be deterministic when its response to input as well as the behavior to the external disturbances is predictable and repeatable. Okay, the response to the input and the behavior to the external disturbances is predictable and repeatable, whereas in stochastic control system the response is unpredictable and it is unrepeatable. Okay. Next is the lumped parameter control system, where it can be described by the ordinary differential equations. For example, the electrical networks with the different parameters such as the resistances, inductance and capacitance, etc. These are the lumped parameter systems. Whereas the distributed control system, here it is described by the partial differential equations and it cannot be physically separated, or the lumped parameters, these are the distributed parameters, these are not physically separated and hence this cannot be represented at a particular place. Example here is the transmission lines. Next is a single input, single output, where you will be having only one input and one output. Multiple input, multiple output, you will be having more than one input and more than one output. One more type of control system is the open loop control system, where it can be defined as a system in which the output is dependent on the input, but the controlling action or the input, it is totally independent of the output or changes in the output of the system. Okay, because you don't have any feedback element here, because of which your input is totally independent of the output. So here you have a controller for which we are giving the reference input R of t. It will generate a actuating signal U, which will be given to the process, and then we'll get the controlled output. So here R of t is the reference input and C of t is the controlled output.